Good day, class. Today ay magdidiscuss tayo ng isang example ng isang Zener regulating circuit. Here are the components of the Zener regulating circuit or the Zener regulator. We have an input DC voltage. We have a series limiting resistor. We have the Zener diode, and we have a resistive load. For the purpose of this discussion, we're just going to use a resistive load. But in real life, pwedeng load natin is not purely resistive. So pwede siyang maging IC or pwede siyang maging transistor. In our previous discussion about the Zener diodes, sinabi ko doon na ang Zener diode should be reverse bias. So tignan natin kung naka-reverse bias ba talaga yung ating Zener diode. As you noticed here, we have the anode and we have the cathode. Ito yung ating input voltage, so positive to cathode and negative to anode. So that is reverse bias. Let us write down the induced polarities of the voltages and the induced currents. For this one, we have plus and minus because it is reverse bias. And then we have plus and minus, we will call this VL, or the voltage across the load, or VRL, which is essentially the voltage across your load resistor. And then we have plus, minus, we can call this V sub R, or the voltage across the series limiting resistor. But how about the currents? For this one, you can call this I sub R, which is yung kuryente na dumadaan sa ating series limiting resistor. Ito naman yung kuryente that goes through our Zener diode when it is regulating. So we can call this I sub Z, or the Zener current. And the last one we have I sub L. Take note of the directions of all the currents in your circuit. Next, we have the circuit parameters. For our input DC voltage, we have 16 volts. For our series limiting resistor, we have a 1 kilo ohm resistor. For the Zener diode, the parameters are the nominal Zener voltage is 10 volts and the maximum Zener power is 30 milliwatts. And lastly, we have the value for the resistive load, which is equal to 1.2 kilo ohms. Ito yung mga pinapahanap sa atin. Letter A, find V sub L, V sub R, I sub Z, and P sub Z. Letter B, change R sub L to 3 kilo ohms and then do letter A again. So titignan natin ano ba magiging effect ng pag-vary natin ng impedance ng ating resistive load. Ang unang dapat natin gawin dito sa circuit na to ay i-isolate muna natin yung circuit and tatanggalin natin yung ating Zener diode. So momentarily, nakahang muna yung terminals ng ating Zener diode. As you noticed here, ang matitira na lang sa ating circuit is the input voltage, the DC input voltage, the series limiting resistor, and your resistive load. The series limiting resistor and the resistive load are in series. So, ibig sabihin nito, magkakaroon tayo ng voltage divider. Yung 16 volts na yan ay nahati sa pagitan ng R at ng ating RL. Our objective here is to solve first for V sub L, or the voltage across the load. So we have plus and minus. That is your VL. Sa circuits 1 na pag-aralan natin yung equation for the voltage divider. So let me just recap that. We have the total voltage divided by the total resistance is equal to the voltage at a certain point divided by the resistance at that certain point. For this one, the total voltage is 16 volts. The total resistance, since they are in series, i-add lang natin sila. So we have 1K plus 1.2K. V sub X now is the unknown value. Ito yung hinahanap natin na V sub L. Ano ba yung resistance doon sa V sub L na yon? R sub L. Therefore, R sub L is your R sub X. Substituting the values, we have 16 volts divided by 2.2 kilo ohms. Dahil inad natin yung resistance ng dalawa to get the total resistance, equals V sub L, the unknown value, divided by 1.2 kilo ohms. Kasi yun yung resistor dun sa ating V sub L. Rearranging our equation to solve for V sub L, or the load voltage, magkakaroon tayo ngayon ng 8.73 volts. So I have rounded off the answer to 2 decimal places. Yung 8.73 volts na yan yung voltahe natin across the load resistor 1.2 kilo ohms. So we can write it down here. So that's equal to 8.73 volts. So what would be the voltage across the terminals of your Zener diode? Diba lahat ng elements that are connected in parallel have the same voltage? Ang RL natin, or ang load resistor natin, tsaka yung Zener diode natin, are connected in parallel. Therefore, they have the same voltage. Kung 8.73 dito, 8.73 volts din yung nandito sa ating Zener diode. The question is, will the Zener diode regulate? Or will it conduct in the reverse bias region? We have 8.73 volts here, but the nominal Zener voltage is 10 volts. As I've explained in our previous lecture, kinakailangan maabot muna yung voltahe across the Zener diode para siya mag-regulate, gumana, or mag-conduct. Kung meron tayong 8.73 volts na nandito sa ating Zener diode, because of the voltage divider, hindi niya kayang abutin yung 10 volts na yon. Therefore, the Zener diode will not regulate. Therefore, if it is not regulating, ibig sabihin, this is considered to be an open circuit. So, itong circuit na nasa baba na to, ito talaga yung equivalent niya. It's because it's not conducting. Let us go back to the parameters na pinapahanap sa atin. For letter A, find V sub L. So, kanina na-solve na natin itong V sub L na to. We have 8.73 volts. But what about V sub R? We can use the voltage divider equation, but we can also use yung pagsusubtract na lang. Okay? Yung 16 volts kanina, as I've said, ay nahati sa pagitan ng R tsaka ng R sub L. Kung meron kang 8.73 volts dito, ilan yung matitira dito? So we have V sub R, that is equal to 16 volts minus 8.73 volts. Kumbaga, itong total, minus mo lang yung voltahe nito para makuha mo yung voltahe dun sa ating series limiting resistor. And that is equal to 7.27 volts. So, nasagot na natin ngayon si V sub L, si V sub R, and the next is I sub Z, or the Zener current. Since the Zener diode is not conducting, therefore it's not regulating, it's considered to be an open circuit. So kapag meron tayong open circuit, ibig sabihin yan, zero ang kuryente natin. Kasi nga walang daanan yung kuryente. Therefore, I sub Z is equal to 0. So it's appropriate for us to write down the unit. So we can write down milliampere as the unit. So nasolve na natin si I sub Z. The last one for letter A is P sub Z, or the power consumed by the Zener diode. So our formula for that, or equation, we have P sub Z, that is equal to I sub Z times V sub Z. This is the basic equation for power. Ibang equation natin for power, meron tayong tatlo. We have I times V, V squared over R, and I squared R. Ang gagamitin natin is IZ, VZ kasi ito na yung given. IZ is equal to 0 milliampere. Bakit? Dahil nga open circuit yung ating Zener diode. Dahil hindi siya nag-regulate. At bakit siya hindi nag-regulate? Dahil hindi naabot yung ating nominal Zener voltage. 10 volts yung kailangan natin, pero ang pumasok sa kanya ay 8.73 lang. Next is multiply it by 10 volts. So basically, the power that is being consumed by the Zener diode is equal to 0 milliwatt. Let's move on to letter B. Change the value of R sub L to 3 kilo ohms. So kanina, yung value ng ating resistive load ay 1.2 kilo ohms. Ano daw ba magiging effect doon sa operation ng ating Zener diode kapag mas mataas yung ating load? The same procedure will be done kagaya ng ginawa natin kanina for letter A. Isolate the circuit and then remove the Zener diode. Tignan natin kung sapat na ba yung voltahe na i-apply natin sa terminals ng ating Zener diode for it to regulate. So for this one, meron pa rin tayong voltage divider. So yung 16 volts na yon ay nahati sa pagitan ng 1K na series limiting resistor at ng load resistor natin na 3 kilo ohms. So the formula for voltage divider will still apply. Total voltage over total resistance equals the voltage at a certain point divided by the resistance at a certain point. Our objective here, again, is to find V sub L. Bakit? Kasi yan yung nakaparallel sa ating Zener diode. So titignan natin kung maaabot ba yung ating 10 volts na nominal Zener voltage. Substituting the values, we have 16 volts divided by 1K plus 3K is 4K equals V sub L. Yan yung unknown na voltahe na gusto nating mahanap. At ang resistance across that is 3 kilo ohms. Rearranging our equation, we have V sub L equals 3K divided by 4K times 16 volts. V sub L is equal to 12 volts. The question is, mag-regulate ba yung ating Zener diode? Magko-conduct ba siya in the reverse bias region? Ang nakuha nating load voltage is 12 volts. Ang nominal Zener voltage natin ay 10 volts. Therefore, it is enough. Kinakailangan natin ng equal to or greater than the nominal Zener voltage. Since mas mataas yung ating load voltage compared to the nominal Zener voltage, our Zener diode will now regulate. So, lalagyan natin ngayon ng Zener diode. Ibabalik natin siya. Okay? If it is not conducting, pwede nating tanggalin because it is an open circuit. But since it is now conducting, ilalagay na natin Zener diode with the proper polarities, alright, and the proper currents. So we have here I sub R. We have here I sub Z. As you notice, ang movement or direction ng ating Zener current is from cathode to anode. Wherein kapag regular semiconductor diode or regular PN junction diodes, ang movement ng kuryente or direction ay from anode to cathode because it's used in the forward bias condition. And lastly, we have I sub L. If we are going to relate the three currents, pumasok yung I sub R dito sa node na to at nahiwalay sa dalawa, we have I sub Z and I sub L. We can write down the equation as I sub R is equal to I sub Z plus I sub L. Pero bumalik muna tayo dun sa mga hinahanap, dun sa mga unknowns. V sub L. What would be the value of V sub L? The question is it 12 volts or is it 10 volts? Remember, nung tinanggal natin yung Zener diode, nagkaroon tayo ng 12 dito. Nung ibinalik natin si Zener, no, ano kaya yung magiging voltahe ng ating load? Remember in our previous discussion, I said there na kapag naabot na yung ating nominal Zener voltage, it will lock on to that particular voltage. So kung na-reach na yung 10 volts, ibig sabihin, ilalock in na niya dito yung 10 volts. Therefore, meron kang 10 volts dito. Ano yung voltage across the load? Since they are in parallel, 10 volts na rin yung ating V sub L. So magkakaroon tayo ng bagong load voltage. We have 10 volts. So this is the correct answer dahil nag-regulate na yung ating Zener diode. It has conducted in the reverse direction. Next, V sub R. V sub R is very easy kasi alam natin kanina na yung 16 volts na yun ay nahati lang into 2. Kung meron kang 10 volts dito, meron kang input na 16, ilan kaya yung ating voltage across the series limiting resistor? So that's essentially 16 volts minus 10 is equal to 6. So let us write down the equation. That is 16 volts minus 10 volts equals 6 volts. So meron tayong 6 volts ngayon dito sa ating series limiting resistor. Ang next unknown value natin is yung I sub Z or the Zener current. So pababa siya from cathode to anode. So how do we get the value of that? Babalik tayo dito ngayon sa equation nito. So we have Kirchhoff's current law. Lahat ng kuryenteng pumasok sa isang node is equal to lahat ng lumabas at that specific node. For this one, we have I sub R and I sub L. Can we solve for the value of I sub R? Yes. Dahil ang I sub R, yan yung kuryenteng dumadaan sa ating series limiting resistor. So let us just write down the equation for this one. So dito tayo nakafocus dito sa resistor na to. We have V sub R is equal to I sub R times R, your basic Ohm's law equation. The voltage across the series limiting resistor R is equal to the current na dumadaan sa kanya times the resistance. V is equal to I times R. Alam natin yung value ng V sub R, na-solve natin kanina ng 6 volts. Ang value ng R ay alam natin na 1K. Therefore, we can solve for I sub R. Rearranging our equation, we have I sub R is equal to V sub R divided by R. So we have 6 volts divided by 1 kilo ohm. And now we have I sub R equals 6. What should be the unit? Di ba ang unit ng kuryente ay amperes? But we are dividing volts by kilo ohms. So the shorthand method to this is, if we're dividing volts by kilo ohms, the answer is automatically expressed in milliamperes. So we have 6 milliamperes. So ang kuryenteng pumapasok dito sa node na to, this is 6 milliamperes. Sunod naman, kinakailangan natin masolve si I sub L or yung ating load current. Bakit? Kasi kailangan natin siya dito nga sa equation na to in order for us to solve for I sub Z or the Zener current. How do we solve for I sub L? So let us focus on this part. Alright? So we can set up the equation. We have V sub L equals I sub L times R sub L. Alam natin yung load voltage. So that is equal to 10 volts because the Zener diode is already regulating. So, ilalock in niya dun sa voltahe na yun na 10 volts. I sub L is unknown. R sub L is 3 kilo ohms. We can now rewrite our equation. We have I sub L is equal to V sub L over R sub L. Substituting the values, we have 10 volts divided by 3 kilo ohms. So I sub L is equal to 3.33 milliamperes. Alright? So we have 3.33 milliamperes na dumadaan sa ating load resistor. How do we solve for I sub Z now? Babalik tayo sa equation na to. So this equation can be rewritten as I sub Z equals I sub R minus I sub L. So I sub Z, which is the Zener current, is now equal to, we have 6 milliamperes minus 3.33 milliamperes. So the answer for this one, I sub Z is equal to 2.67 milliamperes. As you noticed here, meron ng kuryenteng dumadaloy sa ating Zener diode. Bakit? Dahil siya ay nag-regulate. Kanina, sa letter A, nung mababa yung value ng ating load, hindi naabot yung tamang voltahe para mag-lock in yung voltage ng 10 volts. Ngayon naman, nung tinaasan natin yung ating load resistor, umabot na dun sa ating 10 volt na voltahe or nominal Zener voltage. Kaya nag-lock in na siya dun sa voltahe na yon. So it will maintain or it will regulate. So that is what we mean by regulate, to control the amount of voltage. Kaya nagkaroon tayo ngayon ng kuryenteng dumadaloy sa ating Zener diode. Kanina wala dahil hindi siya nag-regulate. Meron pa tayong isang parameter na kailangang isolve, which is P sub Z, or this is the power dissipated by the Zener diode. So ito yung kinukonsumo na power ng ating Zener diode. Babalik tayo sa equation ng P sub Z, basic power equation. So we have I sub Z times V sub Z. So the Zener current and the Zener voltage. Kanina, yung nakonsumong power ng ating Zener diode ay 0 milliwatt. Bakit? Dahil wala namang dumadaang kuryente dun sa ating Zener diode. Ngayon, meron nang dumadaan na 2.67 milliamperes. At bakit? Dahil siya ay nag-regulate. So we can substitute the values for I sub Z and V sub Z. We have 2.67 milliamperes multiplied by 10 volts. We have milliamperes times volts. Ang magiging unit niyan ngayon ay milliwatts. So the Zener power is 26.7 milliwatts. So this is the power being consumed by your Zener diode. How is this important? Babalik tayo dun sa kaninang parameter, the maximum Zener power. Ang maximum Zener power, ito yung maximum na power na kayang i-handle ng ating Zener diode. Anything in excess of this is destructive para sa ating Zener diode. So ibig sabihin, pag lumagpas dito, masisira yung ating Zener diode. Kapag below dito, hindi masisira yung ating Zener diode, bagkus ito ay mag-regulate pa rin at gagana ng maayos. So tignan natin kung pasok. Ang kinokonsumo niyang power ay 26.7 milliwatts compared with 30 milliwatts. So ito yung ating 30 milliwatts. This is 26.7, which is below the maximum value. Therefore, pasok yung value ng ating P sub Z. It means that the Zener diode will properly work and it will properly regulate. Alright. So ngayon naman, isi-simulate natin yung problem na sinolve natin kanina, yung example, using an online simulator which is called Multisim Live. But first is, i-define muna natin ano ba yung tinatawag natin na simulation or computer simulation. So from Merriam-Webster Dictionary, online dictionary, ang definition niya is, this is the act or process of simulating. Ibig sabihin, pagsasagawa ng simulation, a sham object, counterfeit. Ang ibig sabihin niya, hindi naman siya talaga totoo. Meaning, it's not the real resistor, it's not the real capacitor. We're just using a piece of computer software to simulate our circuit. Ito yung pinakamagandang meaning dyan. The imitative representation of the functioning of one system or process by means of the functioning of another, such as a computer simulation of an industrial process. So, ibig sabihin nito, nagkakaroon tayo ng imitative representation. Ini-imitate natin or ginagaya natin yung function ng circuit natin sa isang piece of computer software. So, kagaya itong gagamitin natin. Actually, meron pang ibang computer software for circuit simulation. Hindi lang ito yung pwede natin gamitin. But this one kasi is free and it's accessible online. That's why ito yung papagamit ko sa inyo. Multisim Live is an online Multisim Live is a piece of computer simulation software which is accessible online with online SPICE simulation. Ano ba yung SPICE na yon? From Wikipedia, ang ibig sabihin ng SPICE is Simulation Program with Integrated Circuit Emphasis. So do not worry about the terminologies. Basically, it just means we can simulate the circuit using this software. So dito, naggawa ako dito ng account sa Multisim Live, and then naka-login na ako ngayon, and dito pipindutin natin yung create circuit. Okay, so it also depends on the speed of your internet connection. It's advisable for you to access this using your laptop or your computer. Although I also access this using my smartphone. Medyo mahirap siyang gamitin, no, kapag sa smartphone natin gagawin. Okay, so this is the workspace for Multisim Live. You have different tabs. Ang gagamitin natin na mga electronic components nandito sa left side. So we're going to create the Zener regulating circuit na diniscuss natin earlier. And titignan natin kung pareho ba yung magiging results using simulation. Although there will be certain discrepancies pagdating sa mga values. Okay? But hindi naman siya ganun kalaki. Alright, so we will construct our circuit. On the left side, we have the power supply, di ba kanina? So yung DC power supply. So click on sources, the DC voltage, and then it's just drag and drop. So napakadali lang niya. Yung source natin kanina is 16 volts. So ito-double click natin yan. Okay? And then lilitaw dito sa kanan yung kanyang mga values. Let's just type there 16. And then press enter. Okay? And then click anywhere on the workspace para mawala yung small window or pop-up kanina. And then maglalagay naman tayo ng resistor. So nandito yung resistor natin. Resistor. Alright, so medyo itaas natin siyang onte. Alright. And then ang value nito is 1K. So ang default naman is 1K. So hindi na natin siya kailangan palitan. Pwedeng hindi niyo napalitan yung mga pangalan like V1 and R1. It's up to you. As long as tama yung pagkakagawa ng circuit natin. The next element na nandito kanina is yung ating Zener diode. Alright. So let's just place it here. Ang nominal Zener voltage natin kanina is sa example kanina is 10 volts. So let's just double click this one. And then enter 10 volts. Okay. Pwede rin natin kontrolin, no, using this slider. Pero ako mas nadadalian ako dito sa form dito sa right side natin. Then click anywhere on the workspace para mawala yung small window na nandito kanina. And then lastly, we have the load. Again, you have a resistor. And then just put it here. Then you can rotate it. Okay, and then medyo ipantay natin siya dun sa Zener diode. Okay, you now have your 4 basic elements for the Zener regulating circuit. Okay, and then lalagyan natin siya ng mga connections. Itatapat lang natin dun sa node. Okay, and then merong lalabas na parang pointer. And then left click. And then just connect it. So napakadali lang gumamit nitong Multisim Live. It's just basically drag and drop. Okay. And then connect natin itong nasa taas din. Alright. Then the other one. Kaya sabi ko kanina medyo mahirap gamitin ito, no, kapag smartphone yung gagamitin natin to access this Multisim Live. I prefer using the computer kasi I have a mouse which I can easily use to manipulate the different elements of this software. And then ano pa yung kulang natin? Ang unang load natin is 1.2 kilo ohms. So kapalitan pala natin to, 1.2K. 1.2K and then enter. Okay, and then kulang pa tayo ng ground. Ayan. So sa left-hand side, nandun yung ground. And then kahit saan naman dito. Kasi lahat naman tong part na to are connected. Okay, so you now have the Zener circuit sa example natin, sa first example natin. And then we will put here some annotation para makita natin yung mga value ng voltahe at ng kuryente. So ang concern natin dito is yung voltage. Okay, so lalagay natin siya dyan. And then for current, lagay natin dito. Pwede nating pindutin to, no, yung duplicate na button. So ilalagay natin siya dito sa part na to. Okay? And for some reason kasi hindi na ma-measure yung voltage and yung current dito sa ating Zener diode. So all we can monitor are the currents na dumadaan dito sa ating series limiting resistor and yung dumadaan sa ating load and yung voltage across the load. After you have placed all the annotations, ipipindutin natin yung run simulation. You can press Ctrl R or you can press the start simulation button dito sa right side. So parang play button lang siya. Click natin siya and then it will run the simulation. Okay, so we have the different values, no, for this one. Kanina ang nakuha natin na value for the load voltage is 8.73, so which is malapit na malapit dito sa simulated values natin. 8.73 din ito, no, kapag ni-round off natin. And then we have the current for I sub R is 7.27. Pero kung makikita natin dito, yung current sa ating I sub L, pause muna natin ito, no? Yung makikita natin dito, yung current sa I sub L is the same with I sub R. So ibig sabihin yan, walang dumadaan na kuryente dito sa ating Zener diode. Which is correct kasi yan yung sinolve natin kanina for letter A. No? So 0 ang ating Zener current. Bakit? Kasi hindi pa naabot nung ating voltage yung nominal Zener voltage. Ang kailangan natin is 10 volts, pero ang voltahe is 8.7 lang. Okay? I-perform naman natin yung letter B dito. Ang papalitan lang natin dito is yung value ng ating load, which is 3 kilo ohm. So, iwan natin lahat, no? Papalitan lang natin itong value na to. So, pipindutin natin dito yung stop bago natin palitan yung mga values. So, papalitan ko siya. Gagawin ko siyang 3 kilo ohms. Then, press enter. Okay. And now, isa-simulate natin ulit siya. So, run simulation. And then, the simulator is running. So, ito yung mga na-compute natin kaninang values, no? As I've said a while ago, magkakaroon tayong onting-onting discrepancy pagdating sa mga values. So, dito meron tayong 9.96, which is essentially 10 volts. So, okay naman siya. Walang problem dyan. Ang kaninang na-compute natin dito is 3.33, which is also near the value. Yung 3.32 is near 3.33 na na-solve natin kanina. And then we have I sub R, which is equal to 6 milliamperes, which is ang simulated value natin is 6.04, which is essentially the same. No? Kung ima-minus natin tong 3.32 from 6, magkakaroon tayo ditong value na 2 point something. Okay, so this is how you do the simulation using Multisim Live. So hanggang dito muna tayo, no? If you have any questions, just post it in our group and I'll do my best to answer it right away. So that will be all and thank you.